In this video, I want to see how we can apply differentiation to find the rate of change in something. So the question that we want to use for this discussion is in the given right angle triangle, x is increasing at 2 centimeters per second, while y is decreasing at 3 centimeters per second. Calculate the rate at which z is changing when x is equal to 5 centimeters and y is equal to 3 centimeters. So we are given that this is a right angle triangle. Now for the right angle triangle, we can apply the Pythagoras equation, okay, the Pythagoras theorem here. We can identify which one is the hypotenuse and which one is the two adjacent sides. So if you look at this, where the tip of the 90 degrees is pointing, that one is going to be the hypotenuse. So from the Pythagoras theorem, we can have the square of x is equal to the square of y plus the square of z. This is what we call the Pythagoras theorem. So we can use the Pythagoras theorem to find z. Okay, we are going to find z. But our interest is to find the rate of change in z with respect to t. Since we know the change in x with respect to t, the change in y with respect to t. So we are going to differentiate this equation with respect to t and find the change in z with respect to t. Now, you realize that we are given the value for x, the value for y, we don't know the value for z. So we can start by first finding the value for z using this Pythagoras theorem. So we know x is equal to 5, so we can say 5 squared is equal to 3 squared plus z squared. This gives us 25 is equal to 9 plus z squared. Here we can have 25 minus 16, minus 9, we get 16 is equal to z squared. We introduce square root both sides, we get z is equal to 4 centimeters. Now that we know the value for z, we can find the change in z with respect to t. How are we going to do that? We differentiate this relation that connects the three variables with respect to t. So we are going to differentiate x with respect to t, we differentiate y with respect to t, we differentiate z with respect to t as well. So let's do just that. So if we differentiate this with respect to t, we get 2x, but because we are differentiating with respect to t, we'll put dx over dt. This is equal to, we differentiate this with respect to t, it will be 2y dy over dt, plus we differentiate this with respect to t, we'll get 2 z dz over dt. Now, in this particular statement, we are given dx over dt, we are given dy over dt. What we don't know is dz over dt. We know also the value for z, we know the value for y, we also know the value for x. But you realize that 2 appears on all the terms. So I can divide through by 2, dividing by 2 here, by 2, by 2. I'll get x dx over dt is equal to y dy over dt plus z dz over dt. Okay, so at this point we can replace these things because we know the value for x, we know the value for y, we know the value for z as well. We also know the value for dx, we know the value for dy, we also know the value for dz. So we get them from here. We are told that x is increasing, so we know that increasing is positive. So dx over dt is equal to positive 2 centimeters per second. Then we have dy over dt. We are given that y is decreasing at 3 centimeters per second. So dy over dt is equal to, this is decreasing, so we have to put a negative there. Then what we just don't know is this. So we can press through and just find this one which we don't know. So we are going to do that. So when we come here, we are going to have the value for x is what? We are told that x is 5, so we are going to have 5 multiplied by dx over dt is equal to 2. And this is equal to the value for y is 3. Then we are told dy over dt is -3. Then plus z, we calculated the value for z is 4 centimeters. So we get 4 multiplied by dz over dt. Okay, so now we just simplify and solve for dz over dt. So this will be 10, and this will be minus 9 plus 4 dz over dt. When we take this the other side, we are going to have 19 is equal to 4 dz over dt. Dividing through by 4, we get dz over dt is equal to 19 over 4 centimeters per second. So if you are asked a question why you have to find the rate of change in something, what you have to do is find the equation, connecting the variables, then differentiate with respect to t in our case, then replace the parameters, then you can be able to find dz over dt. You have to pay particular attention to statements like increasing or decreasing. When you see decreasing, you have to put a negative. So this is how you apply differentiation to find the rate of change. So for this and more videos, you can subscribe to our channel. And thank you.